or type a question in chat. All right, recording is starting. Good morning, everyone. Today is Tuesday, September the 14th. Today is the review for Unit 1. Unit 1 is almost over. All right, just so you know, people are watching this recording, there is a password to get into the exam part 1, and the password will be at the very end of this review session. I will probably send out an email to all of you because even though I say this now, I still get a bunch of emails or IMs asking me, what's the password? And this is how it's going to be for every single exam. You know, we do a review session at the very end, you will have the password. All right. This is from yesterday. We did this already. I just want to touch base again, talking about domain and interval notation. You know, we find the VA to be, our domain is everything except, well, -1, right? Because it makes it divide by 0. So there's your hole in the graph. So the visual representation and interval notation is from -infinity up to -1, the union symbol. So you guys make sure, I've had some messages yesterday saying they did the quiz yesterday and they used the letter U on your keyboard instead of the symbol U. So there is there's a button you press. I don't know exactly what the button is, but it's on your screen, some math tools button, and there is a union symbol that you actually click on that will put this in. So this is not the same thing as the letter U. All right, keep that in mind. All right, so yeah, so there's our hole in the graph at -1, and then it goes on to infinity. This second example from 1.08. Now we have two holes in the graph, right? So, we have one at -1 and one at +3. So it goes from -infinity to -1, then from -1 to 3, then from 3 to infinity. So there's the two holes in the graph. There's the visual representation. So just want to show this. If you like, seeing diagrams or graphs to show what the interval looks like, there you go. All right, here we go. Exam review. All right, so on your test. So by the way, guys, if you can do every question in this review, you will do phenomenal on the actual exam. Phenomenal. So really take this review like serious and actually work through these problems and really understand how to do everything on this review before going into the test. So with this review, hopefully there's no surprises. All right, so for this one, you'll be given, zeros, 1 being 4, multiplicity 2, 0, negative multiplicity 3. So before we answer all of these with A, B, or C, what degree polynomial would this be? 6. 6 is correct, yeah. So we got, multiplicity 2, multiplicity 3. This would be multiplicity 1. So, 2 plus 1 plus 3 is 6. So yeah, degree would be 6. Now to answer, A, B, or C. So 4 multiplicity of 2, would that be A, B, or C? B. B is correct. Yeah, it bounces when it's an even. So on your test, it's not going to use bounce. It's going to use the word tangent to. So just take note, when it says tangent to, it means the same thing as bouncing, okay? Tangent means just touches, right? This is from geometry, this vocab word. So tangent and bounces, synonymous. All right. What about the 0 at, 0? A, B, or C? A is correct. Yeah, it's no multiplicity. It just passes through at the, x equals 0, right? All right, and the last one, -1 multiplicity 3. A, B, or C? Yeah, it is C, correct. It crosses while hugging. So that hugging is that little kind of S curved, right? So that's what it means by it's hugging. It has a little kind of curve in there, and that's that cubic. So make sure you understand this, because I don't think it was presented this way in your modules when they use the word tangent to or crosses while hugging. So hopefully that clarifies it. No surprises. All right. So that should be an easy question on the test. All right, next one. Solve the inequality, answer in interval notation. All right, what's our first step in this problem? What's our first step? Multiply both. Well, no. So we don't want to clear the fractions. I know that it's tempting to, but we do not want to clear the fractions. Reason being is you're actually going to miss a hole in the graph, per se, which you will see in the next few steps. So other than multiply and clearing the fractions, we want to avoid clearing fractions. That's a bad thing usually. Well, not usually, but in this case it is when dealing with inequalities. All right. I know this is like, this is like 2 weeks ago, right? 2 weeks ago. What should we do? Come on, there's 13 of you in here. No idea, huh? No idea. How about we move everything to one side? Huh? Does that sound like a good idea, moving everything to one side of the inequality? So this was in the module. So remember, like in the first few lessons, there was some concepts that I just didn't have time to go into. I think we did this one though. I think we did this. Yeah, so we're gonna move everything to one side. I'll move everything to the left side. So we want to subtract that right side, or not subtract it. We're gonna add it in this case, right? Well, so same thing, subtracting. So, I'm subtracting this entire term both sides, right? That's why it looks like this. But in, reality, where we're actually adding it, right? We're really adding it because that's really a negative, which, what I'm doing right here, right? Minus and minus is still a positive. So I'm really adding it to both sides. All right. So, this becomes a plus sign. And look, it's over the common. So we have negative 2x plus 7 in the numerator. All right, so now we have everything on one side. We combined it into a single fraction. Now, does anybody remember what we do next? Yeah, this might have been our first lesson together. Feels like it was a month ago. All right, so for this one, once we're at this point, we have a fraction is greater than 0 in this case. We are going to set the top and bottom equal to 0. The numerator equals 0 and the denominator equals 0. Now, this gives us our critical points. And then we would solve both of them. So we got x equals -1. And then we subtract 7 both sides and divide by -2. So those are the two critical points. So on a number line, I plot those two critical points. Okay. And they're hollow points, and they're hollow because this is not underlined. It's just the greater than symbol. If it was underlined, these would be solid points, but they are not. They are hollow points. So is this looking kind of familiar now? We got our two critical points. Okay, yeah. It's coming back to us, right? It's a good thing we have review, right? All right, so if it's coming back to you, once we have these critical points, what do you think we should do? Well, we just can't write the interval notation. We don't know if, from the points it goes outwards or from the points it goes inward. We don't know that yet. Find points to the left, middle, and the right. Yes, so we're going to test points to the left of the point, between the points, and to the right of the point. So I went ahead and I chose, what did I do? For the first one, I chose 0. So I did the middle of it. So 0 is an easy number, and it's between them. So I tested that. I plug in 0 and I plug 0 into this. We could plug 0 into the original, but plugging 0 into this simplified one, is easier math, I think. So it's fine to do that as long as this is under the assumption that this is actually correct, right? Hopefully this is correct, which it is. So we plug it in and we get 7 over 1 is greater than 7. 7 over 1 is 7. Is 7 greater than 0, guys? Yes or no? Is 7 greater than 0? It sure is. So I'm just going to put a little check mark above it. Oh, my touchscreen's not working. Uh-oh. I'll use my mouse. That's too bad. I have to restart my computer. Anyway. And then we test points to the left and to the right. I chose -2. And I plugged it in, simplified, and I got -11 is greater than 0. Guys, is -11 greater than 0? Yeah, it is not, right? It is not. All right, then lastly, I chose 1 to the right. I chose 4. I could have done 5 or 6 or whatever, even 10. And I got -1/5 is greater than 0. Is -1/5 greater than 0? No again, so I just put another X. So does this all come back to us now, guys and girls? Is this all coming back? Yep. Okay. So now we can see that it only is in the middle. So that means that it connects in the middle. So that means our interval is from -1 to 7 over 2. So that is the answer, which is underneath there. So remember, it's parentheses for open circles, brackets for closed circles, from -1 to 7 over 2. All right. Let's go on. All right. On this page, you can snip this page or come back and watch it later. But I included, 6 more examples for you to work out if you'd like. And the answer key or the answers for all of them are below their respective question. So extra problems for you to work out on your own time if you'd like. All right, decomposition. This is something that we probably forgot how to do it. Remember, we should know that we want to decompose this into, a fraction plus a fraction, right? We should know that, but maybe the steps we kind of forgot. Any ideas of our first step in setting this decomposition problem up? What do we do? Factor denominator. Yeah, so we factor it. And I trust everyone can factor. So we get those. And then from here, what do we do? This is the setup part, right? We don't set it to 0. Nope. This is where we actually we say this fraction equals our decomposition framework. Does that look familiar? We are writing this into the decomposed fractions where we're going to have, some number over our first factor plus some number over our second factor. Looks familiar, right? All right. So then what's the next step? We want to clear the fractions. Now we want to clear the fractions by multiplying this entire thing, by x minus 4 over, multiply the entire thing by x minus 4 times x plus 3 to clear the fractions both sides. And that's how we get this. Okay, now from this point, do you recall what we do? It's been a while, right? This was like a couple weeks ago. Hopefully all of you have hopefully all of you keep organized notes and like label the day by day, and you can flip back to this day. Just having notes on the computer, I don't think is good. I think you really need to handwrite your notes and keep it organized and be able to flip back. So set A or B to 0. So not quite. Now remember, this is where we want to think of numbers that will eliminate these terms. So, what number for X will eliminate this entire term here? What does X have to be? Yeah, X has to be -3. And then to eliminate this entire term, what does X have to be? Yeah, 4. So those are the two scenarios that we need to work out, right? So the first one is when X is -3, and the point, like some of you notice or said in chat that, X has to be -3 in order to eliminate this term. So that's why we chose -3. So we plug in -3 into all the X's. It eliminates this, right? Because 0 times anything is 0. And, so we do the math and we get B is 5/7. All right. So now we have half of the answer, right? We know what B is. So now we have to just do the same thing with X equals, I think we said +4, right? So, there's the work for that one. We plug in 4 for all the X's and we get A is 2/7. All right, so we have A and B. Now we just have to plug it all in, right? So, we got to be careful that we plug in the right numbers for the right place. So A is here. So, and we said A was 2/7. So there's 2/7. And then B was the second one. So we plug in 5/7 for B. All right. Are we done right here? Are we done with the problem? No, good. Now, if you actually did the practice problems like you're supposed to and practice these, you would know that we are not done. So what do we have to do? We have to simplify. How? So let's look at the first one. How do I simplify this? Yeah, so that 2 stays on top, the 7 goes on the bottom in front of the x minus 4. Perfect. And then that 5/7, 5 stays on top, 7 goes on the bottom in front of the x plus 3. Now, that is the final answer. Simple, easy. All right, decomposition. All right, let's go on the next one. All right, upper bound and lower bounds. So what is the upper bound of the function? All right, you may recall how to do this. How do we find the upper bound and lower bound? Not quite. Yeah, we don't have to factor it. We don't have to graph it. No. Yeah, we do use synthetic division, and remember Descartes' rule of sign? Remember Descartes' rule of sign? And we start at 1, right? We start at 1, and this is the one where we have to start at 1 and then go to 2, then go to 3, then go to 4, and so forth. And our goal is to have all non-negative or all non-positive numbers here. Well, right here, all these are all non-negative until we get to the very last one. This ruins it. So that means 1 is not the upper bound. So we would go to 2 and we would check 2. And by using 2, we now have all of these numbers are all non-negative or all non-positive. Well, they're all non-negative, right? So that means that 2 is the upper bound. Looks familiar, I hope. All right, now how do we find the lower bound? There we go. Yeah, so Noah says plug in -x for x. Yep, that's what we should do first. And we do that, and then we simplify it to get this. And then, just like before, we start at 1, and we want to have all of these either be all non-negative or all non-positive, right? So right here, all of these are non-negative numbers, right? Positive, 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 it's neither positive or negative. So all of these are non-negatives. So that means -1 is our lower bounds. Remember, lower bounds, the answer is always going to be negative, even though when doing synthetic, we always use positive numbers here, right? We start at 1, just like up here. If that didn't work, let's say we got a negative right here, we would go to 2, just like we did up here, and do that. So upper bound is 2, lower bound is -1. Descartes' rule of sign. All right, number 10, solving radical equations. All right, what's our first step in solving this equation? Yes, you can use the graph to minimize the guessing, correct. But make sure when you use the graphing, you test what you think is right and test below it too, just to make sure. All right, so for this one, what's our first step? So that would be a good guess. Move everything to the left side. The problem with moving everything to the left side, we can't combine anything. Like this radical 3x plus 7 and this radical x plus 6, these are different. So we can't combine these. So if you move everything to one side, you would have 3 terms, and that's no fun. Now you could do it that way, but you definitely don't want to. Square both sides would be the better choice, yes. Yeah, so we square both sides, and this hopefully gets rid of some of our radicals, right? So yeah, square both sides. Squaring the left, that cancels out the radical. And squaring the right side, remember, we're just, it means multiply by itself. So I just wrote it out twice to show that we have to FOIL it. So, we FOIL it. And I did the work just to save time. But we get those 4 terms. We got 1 plus 1 radical plus 1 radical plus the radical squared. And so the radical squared, well, that part cancels out, right? Squaring a radical cancels out. So this x plus 6 will carry down. We have 2 of these, right? We have 1 radical x plus 6 plus 1 radical x plus 6. So how many of these radicals do we have, guys? How many of those we have? We have 2 of them. Yeah, we have 2 radical x plus 6. Yeah. And then that's, that x plus 6 carries down. Combine like terms, right? We have x by itself. We have a 1 plus a 6 is 7. And then, I just ordered, I put the x in front, I put the radical in the middle, and then I put the constant at the very end. It doesn't really matter at this point what the order is. I just what I did. All right, and then from this point, what should we be trying to do from this point? Yeah, we want to move stuff to the left, and we want to get the radical by itself. Yeah, so move everything to one side. Keep the radical by itself. So we want to subtract the x both sides. We want to subtract 7 both sides to get to here. All right. So we got 2x equals 2 radical x plus 6. What should our next step be? Can we divide out the 2's? Yes, we can. We would divide both sides by 2. Good choice. That will get rid of the coefficients. So we now have x equals radical x plus 6. Now what do we do? We square both sides. Yeah, and that will get rid of our radical, right? So square both sides. Oops, that's the wrong line. We square both sides. And then, based on what I just showed, we would move everything to the left side. So subtract x, subtract 6. All right, we're getting closer, right? The problem's looking like it's a little easier. All right, what do we do next? Yeah, we factor it, right? Simple method. So we get x minus 3 and x plus 2. All of you know how to factor. I trust that. And then we set factors equal to 0 and we solve, right? So we get x equals 3 and x equals negative 2. All right. Are we done? Do we go on to the next problem, or there's something else we should do? Yeah, we need to check the solutions. Guys, always when you have like radical equations and you solve, you always need to check your solutions because they may not work. So let's plug in 3 into the original problem and let's see if it works. So, I plug in 3. I do the math, right? I simplify and I get 4 equals 4. So that one works. So that's good, right? Then we plug in negative 2 into the original problem. And there's the setup. There's this, the next step, simplified work. What's that sound? Do you guys hear that beep? Yeah, I don't know where it even came from. Anyway, yeah, I don't know idea. All right, yeah, so saw someone in chat said that 1 equals 3. So that's not correct, right? It's no good. So that means that this tells us that x equals negative 2 is not a solution. So that means the only solution we have here is, well, x equals 3. That's the only solution. Yeah. So always make sure you verify your answers. All right. Number 11, or not 11, page 11. Okay, graph. This is a freebie. So you'll be given an equation, and like this, you'll be given 4 choices. This is how easy this is. What's a really simple way to find out the answer to this problem? Any ideas? Yeah, go to Desmos and type it in. I'll give all of you like 30 seconds. Everyone go type it in and see if you can figure out what the answer is, A, B, C, or D. The only way you're going to miss this problem is if you don't actually do anything in this class, meaning you don't actually practice your problems after class and do the modules, and you don't actually type this in Desmos to see if you actually know how to do it. And then when you go to the test to actually do this, well, you miss it. All right, looks like a bunch of people typed it in Desmos and they said the answer was B, and I think B is correct. So yeah, this is a good check. You probably know how to use Desmos. So all you really got to do is type it in and check in Desmos. Something else we could have done, we could have just kind of looked at this and maybe figured out the VA, right? Which is at x equals negative 1. So that has a VA at x equals negative 1. So B does, A doesn't, D doesn't, and C doesn't. So really, this problem right here, based on purely the VA being at x equals negative 1, only B has it correct, right? So that's another way you could have done it, was kind of looking at just the parts, right? But you got to be careful in VA because this has a constant. You really want to combine these into a single fraction by multiplying this one top and bottom by, x plus 1, right? So you got to be careful. Having a constant here won't affect the VA, but having a constant here will affect your HA. So if you combine this into a single fraction, you will see what appears to be the HA based on this is not the same as if you were to combine it. But you can do that on your own time. What if the two graphs had the same VA? Well, then we would have to find other characteristics like the HA, which you would have to combine this into a single fraction to determine the true HA. And let's say if both graphs had the same HA and same VA, well, there's got to be something different about it, whether there's a hole in the graph, like this one has a hole in the graph, this one does not have a hole in the graph. So yeah, there'll be different things about it. So you just have to work through it. All right, this one, you have to find the holes. All right, how do we find the holes to this problem? How do we find the holes? Yeah, we want to factor the top and the bottom, of course. All right, so factoring the top is pretty easy, right? You just pull out a 4, right? Why is my mouse working? Oh, there we go. Yeah, factoring the top is pretty easy. Pull out a 4. All right, factoring the bottom, what method did you use to factor the bottom? So, Philip says he does by grouping. Yeah, so that's one method is doing it by grouping. So I'm going to show that way right now. So on the screen, I'm going to show you 3 ways to approach factoring 2x squared minus 7x minus 4. And honestly, whichever one that you think you like the best, maybe do it that way on, going forward. So first one is factor by grouping. All right. So, at 2x squared minus 7x minus 4, we have to split that middle term. And that splitting that middle term, that's kind of guessing and checking. There's really no way of, that I can think of that will allow you to really think of how to split this middle term. Because there's lots of combinations that will add up to -7. So in this case, -8 plus 1 is -7. I could have done -6 minus x. I could have done -5x minus 2x. There's so many combinations, and it's really kind of guess and check. So this is what I came up with: -8x plus x, and plus, the order. Checking the order, is also guessing and checking, right? So I'm not a huge fan of factoring by grouping when you split the middle term like this, just because there's so many things that it could be, and it'll drive you nuts, especially if you don't see the right combination very fast. So I'm not a fan of this method, but I'm still going to show it. We group them. We're going to group these first 2 terms together. So 2x squared minus 8x, I can pull out a 2x, right? So 2x times x is 2x squared. 2x times -4 is -8x. So I pulled out the 2x, and then, x minus 4 just stays x minus 4. All right, next, look, I have an x minus 4 and an x minus 4. So let me, my pen's not working. Dang it. All right, so I'm going to use my mouse best I can. So, I have parentheses around that, right? And there's an invisible 1 in front. That's terrible, but you get the idea. All right, and we can GCF an x minus 4 out in front. What's left over is the 2x plus the 1. So that's how we can get those two factors, right? And then from here, we can see that we have x minus 4 and x minus 4 as the matching factors. So the whole is that x equals what? What is the x coordinate of the whole? Yeah, x equals 4, right? So let's just go ahead and just show the rest of this problem done that way. So all we're going to do is, plug in x equals 4 into, after we cross these out, right, we're plugging it into what's left. So 4 over 2x plus 1. And we're plugging in 4 for the x value to solve for the y value. We've done this pretty recently, right? This, end of last week and I think yesterday maybe. And, that's how we get the answer 4 over 9. So the whole is 4 comma 4/9. All right, so let's go back to factoring this 2x squared minus 7x minus 4. Like I said, I'm not a fan of this method. I really don't like it. I don't think it's very efficient. So another way to do it, what we could do is we could graph. So we could graph 2x squared minus 7x minus 4. So we graph it in Desmos. And when you graph it, one of the factors that we can see really easy is x equals 4. So again, if you graph 2x squared minus 7x minus 4 in Desmos, you'll see it crosses the x-axis at x equals 4. And you can also see it crosses at x equals negative 1/2. But let's use the one that's easier, which is the x equals 4. So if it crosses at x equals 4, and the ideas of how I could use that, there we go. Philip says synthetic division. Yeah, so remember, division is just reducing it, right? So we do synthetic division. So check this out. We use our coefficients. We got the 2x squared minus 7x and then minus 4. We are dividing it by x equals 4. So we do the math, right? Drop the 2 times that 8, add it, get 1 times 4 is 4. Remainder 0, which is what we expected. Now this is reduced by the factor x minus 4. So we have left over 2x plus 1, and then the factor is x minus 4. So this is another way we could have factored this polynomial relatively really easy, because I really don't like this method. You guys like that method better, graphing it than doing synthetic division to reduce it? I know I do. I really like the graphing and the synthetic division. It's like, oh man, it's so straightforward. There's no guesswork involved. The only time that this wouldn't really work is if when you graph this, it doesn't give you a nice number like, x equals 4, right? But the one for this class, your test, it's going to give you a nice number. It kind of has to in a way, or the test will be too hard. Well, maybe not too hard, just harder. All right, let's look at the second method. So this is the method I like when I have to factor, okay? When I taught this like 10 years ago, I called this method the monkey method. And you're going to see why. All right, so we have this here. My mouse isn't working, or my screen's not working. Dang it. All right. So we're going to take this 2, and it's going to swing, and we're going to multiply the 2 times that negative 4. And what we get is 8, right? So when we multiply this 2 times this, we get negative 8. This next line, since we did that, we don't put the 2 now. Now look at this. This problem became a simple method problem. Look at that. How cool is that? So we want 2 numbers that multiply to negative 8 and add to negative 7. What are those 2 numbers? Negative 8 and 1. Yep. Negative 8 and 1, right? All right, we're not done yet. So, if we stop here, our problem will be wrong. So this is, remember, monkey method, so we still have to swing around. All right, what we're going to do is this 2 is now going to swing underneath underneath the 8. And it's also going to swing underneath the 1. Now here's the critical part about monkey method. Once it swings underneath and you write your fractions, you need to reduce this, right? So 2 goes into 8 how many times? Yeah, 4 times, right? So 8 divided by 2 gives us the 4, right? No remainder, right? There's no remainder. So it goes in evenly. Perfect. That factor is done. Does 2 go into 1 evenly? No, it does not. So because 2 does not go into 1, it's like, all right, I'm no good here. I have to swing in front of this x right here. And that's how we get 2x plus 1. Look at that. We get the same factors. Look at that. The same factors. So I call this monkey method. It always works. I really like it. Is this method new to anybody or not new to anybody? It's new to you? Oh. It always works. I don't know. I really like it. Yeah, I like it much better than splitting the middle term and factor by grouping. Because there's no guesswork in here. I don't have to guess, right, of what these numbers might be. This is why I'm not a fan of this method. So this is monkey method. I like it. All right, let's go on. So we saw 4 ways, or sorry, not 4 ways. We saw 3 ways to factor this polynomial, and hopefully one of them you really liked. I like this probably the best, and then this one, and then definitely this is dead last. All right, let's go on. All right, so we got fill in the blanks. Determine if a 0 is a factor. We got the function. So, how can I check to see if x minus 2, how can I check if x minus 2 is a factor? Well, I could check with synthetic division to see if remainder is 0, or I can evaluate what? I can evaluate what? It's a blank. It's fill in the blank. Yeah. I can evaluate f of 2. Where I find it to be, so I'm just going to save you time. When you plug in 2 into the function there for x, you will get 33, assuming I did my math right. So I get 33, which tells me that x minus 2 is or is not a factor. Is or is not? Yeah, it's not a factor. All right. For the bottom part here, now it says, how can I check to see if x plus 1 is a factor? I can evaluate what? F of what? F of -1. Yep. And when you plug in -1 to x, just save you the effort, you get 0. And because we get 0 when you plug in -1, this tells us that x plus 1 is or is not? Is a factor, yeah. So, also a pretty straightforward problem, right? The only way you're going to miss this problem, well, if you don't know what this notation means, which you should, this is pre-calc, right? You've had many past math classes to understand what this means. And then when you actually evaluate for 2, you get the wrong number here, or you evaluate for -1, you get the wrong number here. It's really the only way to miss this problem. And then also, if you can't interpret what it means, if you get 0, it means it is a factor. If you don't get 0, it means it's not a factor, right? So I think this is called the remainder theorem, maybe? I think it's called the remainder theorem. Pretty sure. All right, let's go to 14. All right, we got about 13 minutes left. Got to hurry up. We're almost done. All right, determine the remainder. All right, so right here, I feel like this is not on the test. I think it was last year, and I looked. I couldn't find this problem, I don't think. Or maybe there's one like it. Anyway, we'll still do it anyway. So we got this problem. It says using the remainder theorem, we could evaluate the numerator with what? So Using the remainder theorem, we could evaluate the numerator with what? Any ideas? With x equals -2. Yeah. X equals -2. Yeah, so make sure you're specific on this one. Remember, it's just saying, -2. I understand what you mean, but I think for the test, if there's a question like this, they want you to put x equals -2, not just -2. So evaluate the numerator with that and find the remainder to be -19. Using synthetic division, we also find the same value. Yeah, so remainder theorem. Yeah, I feel like this is not on the test, but it might be in some form. All right, end behavior, super easy. All right, give everyone 30 seconds to answer these 3 questions with A, B, or C. A, B, or C, 30 seconds. Ooh, so I think I know what that noise was. So I get reminders on my computer. So tomorrow, if you didn't know, tomorrow is the first day of Hispanic Heritage Month. Starting tomorrow. Ooh. All right, so the top left, what is that answer? Top left. C is correct. All right, top right, what is that answer? D is correct. And the bottom left? B. Yeah, super easy, right? So this is like, this should be a freebie. These are super straightforward, right? As long as you understand end behavior, right? Now, on your test, they may not present it as my A, B, C, or D. They may actually have you fill in this blank, right? So make sure you know how to go from this to actually fill in the blanks here, right? All right. Next one. What is the domain of the function? I feel like okay, so I use this was from before, right? This 2x squared minus 7x minus 4. Did I use this? Yeah, it's the same one, right? So we can skip the factoring part, right? So guys, how do we derive domain? What do we need? How do we derive domain? What do we need? Yeah, we need the VAs. Yeah, the VAs and the holes. So we need to factor the bottom, right? And this problem was from the previous problem a few slides back when we factor the 2x squared minus 7x minus 4. So I'm not going to show the math again. We all know that's what it is, right? And we know that, we set the factors equal to 0, and we get x equals 4, and we get x equals -1/2. Now we know that x equals 4 is a whole, and we know that x equals -1/2 is the only VA. But remember, it doesn't matter when deriving the domain. Remember, domain uses both the VAs and the whole, so I don't really have to distinguish one versus the other, right? All right, so in chat, go ahead and write out what the interval is based on what I have on the screen here. Let's see if you can derive the domain. And I honestly really encourage you to do this, because we get to see if you actually know how to do it. And prove to yourself you know how. Thinking you know how and actually doing it are two different things, just so you know. All right, Philip, try again. All right. Naomi, Noah, looks good. Yes. All right. So remember, we have to use the VAs and the holes, right? Not just one of them. So those of you that put it in chat, looks like you got it right. And remember, it's also least to greatest. So I did this on purpose. I put the 4 first and then the -1/2. I was really curious to see if anybody would actually put the 4 first and then put the -1/2, which would be wrong, right? Because it's least to greatest. So if it wasn't least to greatest, it would be completely wrong. So be careful. Yeah. So this is also a pretty easy problem, right? As long as you know domain is derived from your VAs, right? Setting them equal to 0 and solving your VAs and holes, that is, and then least to greatest, right? Pretty simple. Yeah, they don't have you do the range on this test. I looked. All right, graph the inequality. All right. So how do we start this one? Okay, so I'm going to talk about this one because I did not teach this one in class. This was part of, I think, 1.02, day one. Is there day one or day two? I forget which one. Probably day two. And this, you had to go into the module and read up on it and practice the problems there. So it wasn't hard. If you actually went there and did it, it showed you how to do it. But I did not go over it, but I am going to cover it right now very quickly. So for this problem, what we have to do is, we are going to simplify this the best we can so far. So we're going to divide both sides by -4. Well, don't forget, when we divide by negative, we have to flip the sign, right? So it becomes a less than symbol. All right. And then from here, we are going to square both sides. And that's how we get rid of the radical. Add 3 to both sides. And we get x is less than 4. So here's the little caveat. If you stop here and you write your answer in interval notation, or you leave it as this inequality form, your answer will be wrong. Because in the module, there was a second part that we had to do. And it was, when you look at this, remember, we only care about real solutions, right? Can we take the radical of a negative number? Yeah, we can. We can if it's imaginary, right? But remember, we want real numbers. So to get a real solution, can we take the radical of a negative number? The answer is no. So what we have to do in this case, and if you went through the module, it says we have to take what's under the radical and we have to say greater than or equal to, in this case, 0. And we solve it. So remember, so our solutions need to be not only this statement, but also this statement. So these are two restrictors. And then we solve, right? So we add 3 to both sides. And we get x is greater than or equal to 3. So this problem says that our solution, x must be less than 4, and it must be greater than or equal to 3. So I like number lines, so I went ahead and I plotted those 2 points, right? So there is my 3. There's my 3. It's a solid point, right? Solid point. And it says x is greater than or equal to that. So that's why I have an arrow pointing to the right. This point says x is less than 4. So I have a hollow point on 4, and it's less than, so it's pointing to the left. Well, remember, this is and. So that means this solution only valid for anything that's in between those 2 points and also including those, including that left point. So, the final graph looks like this. And my answer, which I don't have on the screen and my pen's not working, is bracket 3, 2, 4. 3 to 4. So that would be the answer. If you did not go over these problems in the module, again, I think it's 1.02 day 2, you need to work out some of the practice problems from this. If you look at this example and you do the test question is similar to this, but it's different. And you really need to practice this by going to the module, the practice module, and doing some of these problems to make sure you know how to do it. So this is just one example, okay? All right, let's go on to the next one. How much time we got left? Oh, got 2 minutes. It's the last one, I think. I got 2 more. All right, real quick. All right, find all zeros. All right, for this one, just to save time, 2 minutes left, we want to graph this, and we want to graph that function to see if we can see any zeros, because we're expecting 4. When you graph it, you will only see 2 of them. You will see one at -4, and you'll see one at 3. So we are going to reduce this polynomial by those 2 zeros. So we set up the synthetic. We could do 3 first, or we could do -4 first. It doesn't matter. So I did -4. We do -4. Excuse me. We get remainder 0, like we should, and then we do it again with the other 0, which is at 3. Remainder 0, like we should. And this is reduced by, so this becomes an x squared, right? Because it would be x cubed and then become x squared. So x squared, 0x, and then plus 5. So I write that out. And then, once it's in this form, we just solve for x, right? Subtract 5 both sides, square root both sides. Don't forget plus or minus. The negative comes out in front as an I. And yeah, that's how you get your other 2 answers, plus or minus I radical 5. So the answer is -4, 3, negative I rad 5, and then I rad 5. So yeah, graph it, pull out your 2 answers that you can find, or 2 or more, reduce it, and then solve accordingly. Not too bad if you know how to do it. All right, let's go to the last one. So this one says find the equation of the slant asymptote. So that's an x cubed, that's x squared. This is one higher. So remember, to find the slant asymptote, we have to divide it, right? So I'm not going to do this one on the board, but what we're going to do is do long division and, well, get the answer. So, I think the answer is like y equals x, and I can't do it in my head. So I don't have the answer, so you have to do it. But we did plenty of these, I think. And it is 9:30. So there is the password to get into the test. Again, guys, go through this review again. Pause accordingly, work out some of these examples before actually seeing the work. Make sure you know how to do them all. But it is case sensitive, capital P, so it's polynomials, exclamation point. So that is the password to get in. I haven't uploaded part 2 yet. I have to change something in part 2. So I will upload part 2 document in PDF and Word doc format later today. So look for that. So part 1 of the test is tomorrow. So you can wait until tomorrow to do it. And then part 2 would be the following day. So then we will start on unit 2 on Friday. All right, everyone. Well, good luck. Message me, email me if you have any questions, and see you next time.